Good morning, grade 9s. This video is a little bit different, and that is me narrating for once. This is Mr. Ubrod. And I want to go through 3 questions from the revision test that you wrote today for me. It will be yesterday when you watch this video on a Friday. And before I do that, I just want to look at some quick notes on some of the things I noticed. So let's say we've got 2 lines that intersect. We've got line A, B, and line C, D. And they intersect at some point. And this point over here, we're going to call point F. And the key thing that I want to say is this point here, this is a point F. So F, that green dot, is a point. Just like we imagine there's probably this point B, this point D, this point A, and this point C. So our first thing is that F itself is a point. And the reason I'm saying this is that some of you went and said, well, if we're given that this angle here is 40 degrees, you said F is 40 degrees, but F is a point. So if we want to refer to an angle, then we can refer to an angle, and we can refer to something like, what is angle F, with a little cuppy on top. See the slight difference there? And these are just conventions, so, well learning here. And there are 4 different angles around point F. And let's see, I'm sure I can point it out here, look at that. And so we've got this angle here, that goes DFB. This one here is 40 degrees. There's this angle here. There's this angle here, over here, and then there's this angle here. So let's say we wanted to look at this angle on the right here. How would we refer to it? So we're looking for this angle here. Well, let's go through our letters. So if we were to highlight it, let's see how fancy we can get here. And we go from C to F to B. And that's exactly how we're going to refer to it. We're going to say from C to F to B, and the angle sitting at point F. Then we can refer to that angle. And in fact, let's complete this and head into my next step, which is, what is the angle of CFB? Well, if we look at this line here, CFD, we're assuming that it's a straight line. So we know then that CFB equals 180 minus whatever DFB is, this angle over here, and we know what that is. That's 40. If we make a statement, we need to make a reason, and our reason here is angles. Ooh, that's not a nice angles. Let's say angles on straight line. And therefore we can finish this off and say this is 140 degrees. Notice how we've made a statement on the left-hand side, we've made a reason, and then we've concluded and said what our answer is. And you'll need to get into this habit of writing your statement and then on the other side writing your reason. Okay, let's kick off with our first example of 3 that we're going to do. And it says solve for the unknown values, giving reasons for all your answers. And when it says unknown values, it's basically asking, what is the value of x? There aren't any other variables that are here. And I can see the confusion of these points F, G, and E, and others that looks like we might have had to work them out. But actually, we're just looking for x, and we're going to have to work out what 5x is first, and then from there we'll work out what x is. We've got 2 parallel lines here, or a set of parallel lines, A, B, and a bit of a wonky highlighted CD over here. So if we see parallel lines, chances are we're probably going to use some of the parallel properties. So we're thinking corresponding, co-interior, or going to alternate angles. Well, it's a 3-mark question, so it should guide us a little bit that we should be able to get there straight away. Nothing wrong with taking a more roundabout route, but if we can do it more quickly, let's do it. So I'll start with the quickest and most efficient way, and that is if we look at this transversal running between F and E, and we look at this over here now. hopefully you're already seeing where we're going on this. And we can immediately say, let's see what happens when we add this angle here, plus our 5x, plus our last one, which is 65. And let's write it all down. We've got 40 plus 5x plus 65. Well, that blue thing there is a lovely little cointerior, so it's cointerior, it's going to add up to 180. Whenever we make a statement, remember from our previous one, so I'm just going to write it up here just to remind us, because you'll often get given it in a box format where you've got statement there and you'll have reason written over here. So our statement is 40 plus 5x plus 65 is 180, and our reason is we're looking at cointerior angles add up to 180 degrees, and whenever we say anything to do with parallel lines, we must write down the fact that we're dealing with parallel lines. And our parallel lines here are AB is parallel to CD. Nothing wrong if you said FB is parallel to ED or FG, as long as you're referring to those two parallel lines. Okay, now we've got an equation here. So 40 plus 5x plus 65, however many steps this takes you. I'm going to say 40 plus 65 is 105, plus our 5x still is 180 degrees. Then we've got 105 plus 5x equals 180, and if we subtract 105 from each side, remember whatever we do on one side of the equation, we do to the other side of the equation, and we don't talk about moving things over or trolls under bridges or something. So we've subtracted 105 from each side. That 105 minus 105 is 0, so on our left-hand side we're left with 5x. On our right-hand side we're left with, looks like about 75 or so, and let's divide each side by 5, in which case our left-hand side is going to be x, and our right-hand side is 15, and we can add our little degrees there at the end. Notice that we've got, and I'll say this again, we've got our statement on the left here. Then we write our reason because it related to that statement. For our next statement here, we don't need to write any reason because our reason is just that we're using algebra and adding like terms and everything. So the same applies as we go down. We don't need to write down any sort of reasoning. Our reasoning related to the very first geometrical statement that we made. Geometric statement. Anyway. Right, we've got question 1D here, and again we're looking for all the unknown values. In other words, we're going to be looking for what x is, what y is, and what z is. And it is generally worthwhile trying to do these in alphabetical order, so it's probably going to be easiest to find x first, although we don't need x to find out what y is in this case, but once we have y, you'll see that it's going to be quite a lot easier to find z, so try and do it in order. And before even tackling the problem, it's useful to look at what things do we have of interest over here. So let's just get rid of these things we're looking for, and we say, oh, well, the first thing that sticks out, to me at least, is we got parallel lines. Chances are, see parallel lines, we're going to use them. What else is of interest here? Well, if we look here, this shape here is a triangle, so that might come in handy. Again, might not sure. And then lastly, well, we've got another triangle here. Said lastly, actually, let's go through the other things quickly. Here's a straight line, and here are two angles on a straight line. What else we got? Here's a straight line. There's an angle, there's an angle. Those are going to add up to 180. So there are quite a few things that we might be using in this diagram. And as I said, worthwhile just thinking about them first. You don't have to spend, as I've spent a minute now looking at it, but just quickly glance at the diagram and think, oh, what types of things might I use? And we're looking for angle, let's start with angle x over here. And I'm going to give the game away here by doing that. And let's see if you can see what I'm trying to indicate here. We've got our parallel lines in green, our red going along, therefore that angle and that angle must be equal. Now let's work at how we're going to write this down. So x equals 38. Well, that's a statement. We can make our statement. So, not that one. If we put down that, we're going to put our statements over here, and we're going to put our reasons over on this side. And our statement is that x equals 38 degrees. Straight up we can see it. It looks like the F. Turn your tablet around, you'll see it looks like an F. And our reason here, well, if you remember, the F is corresponding angles. Corresponding angles are equal. You can just write corresponding angles, it's fine. Whenever we write anything to do with parallel lines, we need to talk about our parallel lines. In this case, our parallel lines are the green ones. We've got DE, and DE is parallel to B, let's just fix that E, BC. Okay, so we're looking good so far. Now we've got x is 38. You've got the diagram in front of you, so it's worthwhile just filling that in. 38, now when you're looking at your diagram, we can use that in some way, possibly at some stage. So we're filling our diagram. Let's look at angle Y here. So I'm going to get rid of all these other things, except I'll rewrite that 38 because it'll be useful to remember that we've already worked out that this is 38 degrees. Okay, angle Y. Again, this question's 6 marks. So, and there are 3 things to work out. So it's probably going to be statement, reason, statement, reason, statement, reason. 2 marks, 2 marks, 2 marks. And it is worthwhile using the marks to guide you a little bit. Okay, right. Let's see if our parallel lines can help us once again. We've got BC parallel to DE, and there they are again. And let's look at this bit over here as our transversal, and let's go, well, what happens if we look at that bit in there? Got parallel lines. Again, hopefully it's starting to jump out. It looks like co-interior, so let's see how we can write that down. Statement, reason we've got on the right here. So we're looking at angle Y. Ooh, this is angle Y over here. So Y, if we add it to this angle over here, this 94, then Y plus 94 should equal 180 degrees. Reason, co-interior angles, and something to do with parallel lines. Let's mention our parallel lines. Well, our parallel lines are the same ones we were looking at before. Okay, so let's subtract 94 from each side of our equation. I'm just going to write it above here. It's quite acceptable to do that, or you can rewrite it in the line below. So Y plus 94 minus 94 just gives us Y, and 180 minus 94 gives us 86 degrees. Right, so it's taken us 5.5 minutes because there's been quite a bit of explaining as we've gone along. Okay, so let's get rid of all our previous junk here, but we may as well remember that this angle here we worked out to be 38, and this angle here we worked out to be 86 degrees. And going to be a few ways you could work out angle Z. You could, if you wanted to, work out what angle ADE is, this angle over here, and then from there work out in that little triangle. But if one of the things we spotted at the beginning we think of, we've got triangle over here. What do we know about angles in a triangle? Add up to 180. Notice that in this case it's been useful to work out what Y is already. It would be quite difficult to work out Z if we didn't have Y yet, then we'd have to go via this little angle over here. But we don't have to, so we know that if we add angle Z plus angle Y, and we can just fill it in straight away as 86, plus the angle at C, 38, well, it's going to be 180. Reason, we're adding our sum of angles in triangle. If you had got angle Y incorrect previously and hadn't said it was 86 degrees, don't worry, you'll get all your marks for working out what Z is. And so we got Z plus 124 is 180. Then we're just going to subtract 124 from each side, left with Z equals 56 degrees.